So the common best practices when it comes to deploying Druid in cloud is, let's talk about cloud networking first. It's better to create a separate VPC. That's a no-brainer to deploy your Druid components. But inside the VPC, it's okay to have a single subnet for all server types. So you can have all the master, query, and the data running in the same single subnet inside the VPC. The Druid deployment can span zones inside a region, but not regions. So you cannot have Druid deployment spanning multiple regions, but you can have Druid deployment spanning multiple zones inside the same region. The reason we say that is if you have Zookeeper nodes running in multiple regions, that increases the round trip latency between those communication, and that could cause some issues in the cluster coordinations. Like I mentioned before, expose only the router ports. There are multiple components running inside Druid. Each of them are exposing APIs that you could use to call them. Like example, you could talk to Overlord and ask for the list of tasks, but router acts as a management proxy inside Druid, and you expose the router port, and router can route the traffic to the appropriate components inside Druid. All right, so let's talk about virtual machines. So the master data and query are pretty much your virtual machines when you're running in AWS or GCP or Azure or in your own data center. So the master servers needs a reasonable amount of memory and CPU, and it's better to have a local SSD for that. The reason is the Zookeeper is running in the master nodes, and it's better to have a faster drives for it to store for its data drive. So the latency will be much more faster there. For data nodes, for data server types, it needs a lot of memory and more CPU. These are the set of historical nodes, historical processes running inside the data nodes, and they're the one that are answering your queries from your immutable segments that has been ingested into the Druid cluster. And they would need a lot of memory and more CPU. More the CPU it is, the more parallel it could run your queries, more parallel it could read the segments. And it definitely helps with having a local SSD for your data servers, so it could read the segment in much more efficient and a faster way. And we recommend using NVMe drivers for local SSDs, so you could get better throughput of reading the segment files from a disk. The query servers, they are not interacting much with the disk. They're not storing much data and reading data from the disk, but they're very memory intensive. This is where your brokers are running. The brokers are merging partial results coming back from your historical data nodes. So it's better to have more memory in your query nodes. Security, Druid components can be SSL enabled. So we recommend to have encryption between the Druid components, and Druid also supports authentications and authorization, where you can configure your own rules, roles, and then provide permissions to the appropriate users to the data sources. From a monitoring perspective, Imply provides a product called Clarity. It's an APM product for Imply and Druid. So it's very tightly integrated with Druid. The Druid cluster emits a lot of metrics. Clarity captures all of them and provides an easy and efficient way of digging deeper into what is happening inside your Druid cluster, what's happening to your query performance, what's happening to your ingestion. In the case of a real-time ingestion, do you have any Kafka lags or back pressure that's building up when you're writing and publishing the segment files? So Clarity is a great tool for APM. There are other tools that you could use as well to collect the metrics that Druid is publishing. Especially, you could use StatsD and emit that to a Datadog if you're a Datadog shop. The next thing is the data tiering. A lot of our customers use data tiering way to slice and dice that hot tier versus cold tier. Say, for example, if you have a data source that needs to be performing um, uh, really good, and you want to make sure the most amount of CPU resources and memory are being allocated to that data source, then you group a set of historical nodes and then create tiering like an hot tier and a cold tier, and then ingest a data source that requests more performance only in the hot tier, whereas the data source that doesn't need much of a performance into the cold tier. There are other ways to make use of the tiering strategy. There are some customers of ours who would deploy it in this way, which is there's a data source for which for the first 90 days, you want to be really high performance queries should be allowed in the first 90 days. And after 90 days, it's okay to have a lower latency. Then you can have a retention rule set in such a way that the first 90 days of data goes into the hot tier, the remaining 90 days goes into the cold tier. So you can use the data tiering to slice and dice your data in that way. So Druid also supports caching. There's an historical level caching, and you could also set up caching at the broker level. We recommend not to set up caching at the broker, but rather set up on the historical level, historical nodes. And Druid supports level 1 and level 2 caching. You could also have caching externalized to a memcache as well, or a Redis cache. By default, Druid maintains the cache and the JVM memory, and we use what we call as a caffeine cache. And if you use the default, then you have to make sure that you increase the JVM heap size for the historical nodes.